Assalamu alaikum jami'an, good afternoon. Now we're going to start with chapter 3 where we're going to talk about overview of natural gas processing. In this chapter we will talk mainly about certain points that we have discussed already in the previous two chapters, but we're going to emphasize on the main products or the mainstream coming from natural gas processing, and we're going to discuss what are the main units included in natural gas processing. We're going to talk also about natural gas compression as well. So in this chapter will be the main output of this chapter, or the main outcome of this chapter, is to introduce you to what we call the natural gas processing scheme, or what do you mean by the natural gas processing, or what's the process flow diagram for natural gas processing. And then we're going to discuss these units or these subunits in the natural gas scheme in the next few chapters. So in this slide we will be exposed again to a list of objective or list of the main objectives for what we call the natural gas processing, or why do we need to do natural gas processing. We have already explained most of these points, such as the removal of water, because or the what we call the dehydration. The main objective or the main reason for this is that the presence of water improve the condition to form the gas hydrate. So we wanna prevent the formation of the gas hydrate due to the presence of water, so we remove the water, and we also need to remove the water to improve the calorific value of the gas or the produced gas. And then the removal of acid gases such as H2S and CO2, because they are toxic gases. They may cause or contribute to the corrosion of the equipment, and they may also reduce the calorific value of the produced gas. Removal of nitrogen also, removal of nitrogen is very important as well, is very crucial for the reason that the presence of nitrogen at high quantity will also reduce the calorific value of the gas. Helium recovery, that is also important because helium is very expensive sometimes, so once you recover the helium and you can sell it as a separate product. Removal of NGLs, or what we called before as natural gas liquids, where we talked about them as highly expensive or expensive compounds that we can fractionate it. And the LNG production. We have already discussed most of these objectives or most of these points in the past few lectures, but now we're gonna just emphasize on this, and this is the main, and because this will be the main objective for the chapter, or these are the main components that we will discuss in this chapter as well. This slide also discusses another interpretation for the natural gas processing, because as we know, natural gas is mainly used as two things: as fuel, first of all, could be used as a fuel, or as a petrochemical feedstock, where you use it as a feedstock or raw material to produce sometimes highly expensive chemicals or highly expensive material as well. Therefore, the gas composition, the main composition of the gas will determine what will be the price or what will be the economy of or the value of your gas. For example, if you produce a gas that is really highly rich in CH4, which is the methane, and one that has very little bit of CH4, so let's say that this one has 90% CH4, and this one, for example, let's say that has 80%, and this one has, for example, so this means that the one that has 90% CH4 will have better economy once compared to the 80%, in case that the 90% mean that this is like 90% CH4, and the 10% include all the other heavy fractions and the CO2 and N2, and the 80% will include also, for example, this means that it's not necessarily, but it might include that you have high percentage of CO2 and N2, which means that you need to remove these portion of material in order to improve the quality of the gas sometimes. So this means that the composition of the gas will determine the economy of the gas, and as we explained earlier, that the composition of the gas also means that what kind of heavy fraction do I have, C2 plus or C3 plus? Do I have really rich gas or lean gas as well? Because the presence of these heavy fractions also will improve the quality of the gas and will determine the economy, or will allow you to sell the gas at higher prices, for example. So the main reason for gas processing, as we explained earlier, but you can here classify them or give them another classifications. First of all is the purification, which is the removal of substances that might really inhibit or that might prevent the selling of natural gas, or that might reduce the calorific value of the natural gas, such as N2, CO2, H2S as well. The second reason is what we call the separation. When you separate, you mean separation is similar to what we call the fractionation. In the fractionation, you split these gas stream or these component into different streams. So you get the natural gas stream, you get it into a unit, and this means that you will split it into different streams. So this is CH4 or C1, this is C2, C3, then you get, for example, N2, you get CO2, and you can sell each one separately. So this is the second reason for the natural gas processing. The third one is what we call the liquefaction, where when we do the liquefaction we do one thing, which is the positive energy density for transportation and storage, which make it, as we mentioned earlier, liquefaction means that you convert the gas into liquid in order to reduce the amount of volume that you are processing or you are transporting or you are storing as well. This means that you are condensing or you are increasing the density of the gas inside, or increasing the energy density in your stream or in your component or in the gas. So when we talk about liquefaction, you convert the gas into liquid to reduce the amount of volume of the gas that's needed to be transported or storage, and this means that you are in fact condensing or you are concentrating the energy in small quantity of the gas instead of large quantity of the gas in the gaseous phase. You normally do purification if you are dealing with a small volume of gases, because you need to remove these, for example, the CO2, the N2 as well. But if you deal with the large volume of the gas, normally you do what we call the fractionation, because the fractionation means that you have high content of, when you do separation, means that you are dealing with high content of C2, C3 in addition to the N2 and CO2. So it doesn't work to do, for example, if your gas stream include mainly CH4 and very little quantity of C2, C3 and high quantity of N2 and CO2, you will not do fractionation. You will do purification, where you remove the CO2 and the N2 and the H2S, and you will do what we call, or you remove the traces of helium, for example. But if your gas stream include like large content of C2, C3 and some other component, you do the fractionation or you do the separation of that, because it's worth money wise to do the fractionation process in order to produce more gases or more valuable gases. In this slide, I'm just giving you just to refresh your memory about these terms that we have learned before as an NG, LNG, LPG. So we have already explained all these terms in chapter 1. So this is for your reference if you want to get back to this slide or to these classification in this chapter as well. Normally, what kind of processing is required will be determined by the quality of the gas that you are interested to produce. For example, okay, so here, this is what we mean. Here, for example, this is what we call the natural gas processing. So what I'm saying here, that what kind of process you have here included this natural gas plant, or the type of process that's required, will be determined by mainly what will be the quality of the gas that you are producing, and also what will be the quality of the input gas as well. So I will determine what kind of gas processing I need based on two things, or based on one thing specifically, or in more details on specifically in one thing, which is the quality of the gas that I want to produce, or what will be the desired quality of the gas and the product, but also the composition of the gas and the condition of the gas at the inlet of the natural gas processing plant is also important parameter to determine what kind of process do I need to do, for example. But the main purpose for gas plants is what we call the dehydration, which is the removal of water, the associated gas stabilization, and we're going to talk about this when they are dealing with natural gas associated with oil, for example. And the third one is what we call the removal of carbon dioxide and nitrogen for the EOR, where EOR stands for the enhanced oil recovery, which is like something related to the oil exploration and oil extraction from the reservoir rocks. And then upgrading of sub-quality gas, which is the removing of N2, H2S and CO2, which is the sweetening unit, and the removal N2 using what we call the cryogenic unit as well. Helium recovery and liquefaction. This is again similar to what we have already explained earlier, but this is to give you an idea how the quality of the gas or the quality of the produced gas determine or dictate what kind of process you need to implement in your plant. Because for example, if you are dealing with natural gas stream, for example, that has very low concentration of H2S and CO2, most specifically H2S, which is sometimes the case, and I think even in Oman there are some natural gas, some gas field that has very low quantity of H2S, then this means that you don't need a treatment unit for the H2S. This means that you can simply use or produce your gas without passing the gas stream into what we call the H2S removal unit. In this slide now we're going to start talking about what we call the natural gas processing flow sheet, or the process flow diagram for the natural gas. What are the main unit included in the natural gas processing, or what can be, or what will be the phase of this material? Is it gaseous phase or liquid phase? For example, if you look at this process flow diagram or this flow sheet for the natural gas, then we can split it into different sections that we're going to talk about in details later on. But as a guideline for this scheme, you can simply say that the first thing is that the black lines denote liquid, which means that if I'm dealing with any of these lines, this means that I'm dealing with liquid phases. Okay, and the less common process are in shaded color, which means that if you go to the plant, you will not find, not every plant will have helium recovery unit, not every plant will have nitrogen rejection, and not every plant will have liquefaction unit. So these units are not commonly found in most of the natural gas plant. They are found based on the quality of the gas inlet and the gas outlet. So this is like not very commonly found units, which are the three major units, especially. But nowadays you can find nitrogen removal unit are available in most of the gas plant nowadays, but helium 1 and liquefaction 1 is not very commonly found. And as we explained earlier, the major four steps or major four operations, which is the H2S removal, the dehydration, the CO2 removal, the compression as well. And then we have something called what we call the inlet receiving unit, where in the inlet receiving unit you remove solids, you remove condensed H2 or remove the water, for example, and you remove some of the hydrocarbons liquids as well. So we're going to talk about these details later on step by step, but this is the stream from the point where you start from the gas or liquid from the wells to the point where you start to produce natural gas liquids and natural gas as well, and what we call the shale gas or the natural gas, the CH4, the one that you use it at home, for example, as an end user. So if I want to look at this slide or this chart or this flow chart that describe the major unit for the natural gas plant, I'm gonna split it into small units now, where the first unit will be about the separation, and this is gonna be the next chapter that we're gonna discuss in here. So this is what we call the liquid gas separation, for example. And also it might also include liquid solid gas separation, where you're gonna separate the gas from the liquid from the solid. You're gonna remove some of the sands or some of the solid material, and you're gonna also remove the water droplet that are trapped already in the gas stream, and we're gonna look at the separator design. And then the second unit will be what we call the sweetening unit. In the sweetening unit you will remove the H2S and the CO2, and then the gas will continue to go. And you can see that here there's one auxiliary unit, which is the sulfur recovery unit, where we're going to talk about Claus process. We're going to discuss it also in chapter 8, I guess, or what you're going to do with the sulfur once you recover the sulfur, or once you remove the H2S from the gas stream. What will you do with this sulfur, for example? And then you will go for the next stage, which is the dehydration unit, where you remove water mainly from this from the gas stream, and then you go further to the subsequent section, where you're going to talk about the NGL separation, the nitrogen removal, and the helium removal, and the liquefaction. So these are the main units that you're going to see when we talk about natural gas. So here from the well, or here's the gas stream at the inlet, where it goes first to the liquid gas separation or liquid gas solid separation unit. So this is unit 1, I'm going to call it. This is then the gas stream will continue to go to the sweetening unit. This is unit 2, and then it will go to the dehydration, which is unit 3. The sulfur recovery unit is like auxiliary unit, or what we call not a major unit, but it's the process where you take the H2S and recover the solvent that you use to remove the H2S from the gas. You recover the solvent and you take the H2S and you convert it into sulfur, elemental sulfur. And then you're going to talk about the subsection unit, or the other unit, which is the NGL separation, the nitrogen removal, and the helium removal, and the liquefaction. So now I think it's clear from now on what we're going to talk about. So this slide, please make sure you keep in mind this chart, because this will keep, and I will show this chart at the beginning of each chapter to keep you linked and to keep you connected to what we are talking about, or what we're going to cover in this, for example, chapter or the next chapter. As I explained in the previous slide, that natural gas started, or natural gas processing starting from the gas inlet stream from the well to the point where you start to collect the product that you are looking at, as an NGL, for example, or natural gasoline, or liquefied natural gas, or as a shale gas as well. And this will include several units, such as, I'm gonna just use different color just to make, and your process units or your process scheme will include the major unit, which is the field processing, inlet and outlet compression, gas treating, dehydration, hydrocarbon recovery, N2 rejection, liquefaction, liquid processing, sulfur recovery, and storage and transportation. And now we're gonna talk about each of these process, or each of these units, and we're gonna show you exactly where it is located in the flow chart, or in the natural gas processing flow chart. So the first unit, we will talk about what we call the field operation and inlet receiving. In the field operation and inlet receiving, which is the first step, which is the first unit that the gas will enter, has several rules or several duties. The main duties is to do what we call the gas liquid separation, or to remove the liquid from the gas stream, to do the dehydration, to prevent the formation of hydrate, and to remove H2S and CO2, and to do what we call the inlet compression. And what does that mean? This means that, because normally you will extract the gas from the field, and then you will ship it through pipeline, you will transport it through pipeline to another location, which is the natural gas plant. But normally you will do something on site, which means that this processing, which is the field liquids removal, where you remove the liquid from the gas, the acid removal, where you remove H2S and CO2, the dehydration, the removal of water as well, and the field compression, sometimes it's done also on site, where the gas field also will have units that deal with these scenarios. And why is that? Because it's so important, because sometimes during the transportation of the gas, you want to make sure that the hydrate will not form during the transportation of the gas. So you want to make sure that you reduce the quantity of water to an acceptable level, that hydrate will not form, for example, during the transportation between the gas field and the natural gas plant. So here I'm talking about what we call the field operation. This is field operation, means that I'm extracting the gas. Here is my gas field, for example. Okay, here is my gas field, and I'm doing most of this processing on site in the gas field, which means that I can remove part of the water, I can remove liquid, I can remove the gases, and I can do what we call the compression on site in the field itself. The second unit will be when you are talking about what we call the inlet and outlet compression, which means that you're gonna compress the gas, and this will be different from one point to another point, where the gas compression requirements will be different from one section to another section. For example, during the plant, or at the inlet, is gonna be completely different than the compression requirement at the outlet, based on the composition, because normally you will require what we call the high pressure if you are processing your gas through what we call the cryogenic unit. So for example, if your plant includes the cryogenic unit, you need to compress the gas at relatively high pressure, and you're going to use different type of compressor that we're going to expose to also toward the end of this chapter, in order to achieve this this pressure system that you are required, or this value of pressure. But this doesn't mean that all the value of the compressors, or the value or the pressure or most of the compressor will give me the same pressure. No, it means that you have different pressure requirement, which means that you will use different compressor based on the process that you are bringing the gas to. And the third unit when we talk about natural gas processing will be the gas treating or the gas removal. When we talk about gas treating, so the term gas treating, gas removal, sweetening unit are all the same concept. In this gas treatment unit, you will remove mainly H2S and CO2 through what we call a different process. One of the major process that we're gonna look at is what we call the amine absorption, where you're gonna use the different type of amine to remove the H2S and CO2 from the gas stream. And you can also see that you can also use different other processes that also can be found in some of the plants in the world nowadays, such as adsorption process, membrane process, and the bacterial desulfurization. And we can discuss what do you mean by bacterial or the removal of, for example, sulfur using bacteria toward the end of this chapter as well. And then the fourth unit will be when you talk about the gas dehydration, and the term dehydration means that we're gonna remove the water to prevent two things: to prevent dehydrate formation and to improve the quality of the gas, or to increase the calorific value of the gas. And this is where the location of the dehydration unit, it's gonna be after the exactly gas treating unit, for example, or gas, or what we called before, this is gas treatment unit, or what we call the sweetening process. And you can do the the dehydration using different approach. You can do it through absorption, adsorption, membrane, and compression. And we're gonna see the difference between what we mean by absorption process and adsorption process later on also. Another major unit that can also be found in natural gas processing plant is what we call the liquid recovery unit, which is this unit here. And you can see it's directly after the dehydration. So after you get the gas from the well, you do the the field treatment, you bring it to the compression, and then to the gas treatment, then from the gas treatment or the removal of H2S and CO2, then to the dehydration where you remove water, then you do what we call the hydrocarbon recovery, or which is the process used to recover or to remove or to fractionate the what we call the NGL or natural gas liquids. And this is required to recover valuable hydrocarbons, which is very expensive hydrocarbons, by the way, and to adjust the specifications such as the hydrocarbon dew points as well. And normally in the hydrocarbon recovery you will utilize what we call cryogenic separation, or the cryogenic process, where you're going to use a specific type of heat exchanger to bring the temperature very low to very low temperature values, where you can separate or you can liquefy or you can recover these natural gas liquids from the gas stream, or collect these natural gas liquids from the gas stream. And I think the flow is logically so far, because it doesn't make any sense to start doing, for example, the natural gas liquid recovery or the liquid recovery before the gas treatment or before the dehydration. So as it is, the flow makes sense. The gas will then go to another major unit, which is called the N2 rejection and H2 recovery. And as we explained earlier, these two units are not very frequently found in the natural gas plant, and even though like nitrogen rejection unit will be found more frequent than the helium recovery, the nitrogen rejection normally will be done using what we call the cryogenic process. And that's why we said that you need sometimes to do what we call the pressurizing system to a high value in order to drive or to make sure that the cryogenic process or the cryogenic separation will be done. For the helium recovery, which is not commonly used, it will be done normally if you have a helium content of 0.5%, and it can be done due to many reasons. One of the main important them is the quality, or the value of the helium, because as you know, helium is very expensive component, and if you can recover it from the gas stream, although it is available at 0.5%, but given the fact that you are processing very high quantity of the gas every day, this means that you can recover a large quantity of helium per day. and given the fact that it's very expensive, so the process is feasible. The only issue with the process of the helium recovery, that the helium recovery is not an easy process. It cannot be removed easily. You need specific process. You need cryogenic unit, you need, for example, pressure swing adsorption, or you need specific type of membrane, or what we call the metal membrane, or the membrane separation unit using a metallic membrane, which is also very expensive and very hard process to be operated. Sulfur recovery unit is the process where you're gonna recover, or what we call the sulfur, or what you're gonna do with the sulfur, because you know the gas sweetening unit, which is the gas treating unit, will give you what we call the solvent, such as amine, for example, and the solvent entrap the H2S inside it. So you take the gas stream of, which is, you take, for example, the solvent stream, which is rich with H2S, and you bring it to what we call the sulfur recovery unit, where in the sulfur recovery unit you will remove the SiO2 and you will recover the solvent, and you will remove the sulfur and you convert it to what we call the elemental sulfur through what we call the Claus process. And we're going to discuss the Claus process, I think, in chapter 8, and we're going to see how it's thermally driven process and how you can convert the H2S, which is a poisonous gas, to elemental sulfur, which is S, or the solid state sulfur, which is like highly used in fertilizer industry and polymer industry as well. And the process, or the cloudy process, as I explained earlier, it involves a lot of partial oxidation of H2S into S2, followed by reacting S2 with H2S. So we're going to see what are the details of this process, but for the time being, you need to understand that sulfur recovery process sulfur recovery process means that you're going to take the H2S from the liquid stream, or from the solvent that capture the H2S from the gas, and then you're going to separate the H2S, or you're going to convert the H2S into what we call the elemental sulfur through what we call the Clausius process, which is basically partial oxidation process of H2S to SO2. One last process that we're going to discuss in the natural gas processing flow chart is what we call the liquefaction process, where it's located here. As you know, that after the gas pass through what we call the gas treating, hydrocarbon removal, the dehydration as well, the helium recovery, and the nitrogen rejection, it goes directly to what we call the liquefaction unit, where in the liquefaction unit you produce what we call the LNG, where you convert the gas stream into liquid stream, and this means that you are reducing the volume of the gas at the end of the day, because you are converting it from gaseous phase to the liquid phase. And this means that the product that you are getting will be higher in terms of energy density. You are concentrating the energy in your gas, for example. You will require less space and less storage and shipping cost, and it's more safe. And one of the main process used to do what we call the liquefaction is the cryogenic process, that require very dry natural gas. And we're going to talk about cryogenic process later on once we go through the material. I think we're going to discuss it more in chapter 5 or 6, I guess. Some other unit also that you can find in the natural gas processing plants is what we call the storage and transportation unit. For example, the utilities, which is the power generation, the heating fluids, the cooling water, the N2 purging gases, the fuel gas, the air gas used for the control valve, or the automated control valve as well. Other consideration also that we're going to look at is what we call the process control, or how do we do some other points that's really required to know, at least to have the basic knowledge about, is what we call the process control for the natural gas processing, where you can use what we call the digital control system, DCS, or the advanced process control, which is APC, and you can use also the SCADA as well. And the safety of the system, also the safety of the process, where you can where we're gonna talk, or you can include the emergency shutdown of inlet gases, the relief valves, the vent system, the flares. Most of these terms you have seen it before in some other courses, such as safety and process control, but here is you're gonna see the application for this, but we are not gonna really spend a lot of time on them. So it's just like for you to give an idea about what also could be included in any natural gas processing system, or any natural gas processing plant in the world, that you also, in addition to the storage and transportation, you can also find what we call the process control system and the safety system, in order to ensure the safe operation of the system and safe handling of material, and in order to ensure that you are fully control the process in order to avoid any odd or weird situation.